Welcome back, learners. As you are aware that we are studying chapter 3 atoms and molecule, and our today's topic is atomic mass. Look, if you see the word atomic mass, it simply means mass of an atom. We know that atom is the smallest particle which take part in a chemical reaction. Students, the atomic mass may be expressed in any unit of mass. You can express in gram, in kilogram, but the actual mass of a single atom is very small. An atom of hydrogen, which is the lightest atom, is having this much mass. Okay? If you don't want to put this much zeros, then you have to write this number in scientific notation as 1.673 into 10 raised to power minus 27 kg. Such a small number. Okay? You have to remember these things. Now, it is not possible to measure such a small mass even with the help of most sensitive balance. Such small number are not very convenient to write also. You can see you have to put so much zeros, or otherwise you have to write such a big number. Big number in the terms of digit, okay? The value is very small. That's why IUPAC has accepted the atomic mass unit scale to be used for expressing atomic mass. And this was done in year 1961. In this scale of atomic mass, the carbon-12 isotope that has been assigned an atomic mass of 12 AMU. Now this is a new thing, AMU or U. So let's explore about it. Our next topic is, what is the atomic mass unit? So students, atomic mass unit, which was earlier abbreviated as AMU, but according to the latest recommendation by IUPAC, it is written as U, which means unified mass. Now you must have understood that it is the unit which will be used to express the mass of an atom in place of gram, kilogram, just because they are a very big unit when we compare it with an atom. So now we are going to understand what is 1 AMU. The mass equal to 1/12 of mass of C12 atom. That is your 1 AMU. Here the definition has been written, you can check. It says, one atomic mass unit is the mass unit equal to exactly 1/12 the mass of one atom of C12. If I tell you the relation of this AMU with gram, students, 1 U is equal to 1.66 into 10 raised to power minus 24 gram. So, we hardly able to differentiate a difference of mass of 1 gram in any object. And this U is that much smaller than your 1 gram. So, let's explore more about it. Here you can see an image. Look, here the relation has been written. 1 AMU, as I earlier told you in the definition, if you're going to write the formula for it, you will say 1 AMU equals to mass of C12 atom, that is the isotope of carbon. Actually, carbon is having 3 isotopes. One with mass 12, other with mass 13, then 14. Out of which the C12 that has been selected as its reference is the most abundant one. Now, the absolute mass of this atom is 1.9924 into 10 raised to power minus 23 gram. This has been found out with the help of instrument. Now, if I want to know the relation between gram and 1U, atomic mass unit can be said, but as you must consider the recommendation. As per that, now we use 1U. So, if you divide this number by 12, you will get the relation, and the relation is this number. Now students, we will study that is atomic mass unit a practical unit? The atomic mass unit is not a practical unit because it is equivalent to a very small number. Here you can see the relation. If I going to write this relation in kilogram, then I will have to write 1U equals 1.66 into 10 raised to power minus 27 kg. So, still a very small number. Such small masses cannot be measured on any balance. That's why I have told you that atomic mass unit is not a practical unit. Now students, We have understood this concept. I'm adding one more term, which is your relative atomic mass. But before that, let me explain you one example which will help you to understand this concept. Now here you can see a picture of watermelon. Then you can see 12 pieces of watermelon has been placed here, then a single piece, then you are seeing a balance. So what's the story? Imagine that a fruit seller is selling fruit, but this fruit seller is not having any standard unit, okay? He is not using any standardized weight, which you normally see. Now, he has taken the watermelon and he is saying that this watermelon has mass equal to 12 unit. For simplification, you can say 12 watermelon unit, or you can say 12 fruit mass unit. Now this fruit seller is very expert in cutting and he has taken out 12 slices out of that watermelon. Each of the slice is of same size. Okay, so all must have same mass. Now what is the mass of a single slice? I know you can easily tell. It's 1/12 of the watermelon. What was the mass of watermelon? It was 12 fruit mass unit. Now a single slice would be, yeah, you can tell, 1 fruit mass unit. Now we know that what is the mass of this single slice of watermelon, and here you can see this fruit seller is selling other fruits. Here apple has been placed, so 2 apples are having mass equal to 1 slice of that watermelon. So they are having mass equal to 1 watermelon, or you can say 1 fruit mass unit. So in this manner you have seen that how a watermelon entirely different unit can be used to weigh the other things. So now this fruit seller is selling all the fruits using this slice. So he is just selling the fruit as per the relative mass of the fruits with watermelon. Okay. He is comparing the mass of all these fruit with the mass of watermelon and then selling it. Now you must have understood this concept. So let's go back to the atoms and there we will study this relative atomic mass. Now here you can see heading relative atomic mass. First of all, we will define it. So listen to the definition carefully. It's a bit important. The relative atomic mass of an element is defined as average relative mass of an atom of the element compared with the atomic mass of C12 isotope. So, in order to find out relative mass of any atom, you have to compare its mass with that C12 mass. Okay, let me show you the formula. Students, you can clearly see the formula. It says relative atomic mass of an element is equal to average mass of one atom of the element which you want to find out divided by 1/12 mass of C12 atom. C12 is the isotope of carbon which we are discussing for so long. Now here you can see relative atomic mass is just ratio of two masses. So whenever we find ratio, that time we are not having any unit. That's why relative atomic mass is a pure number. It has no unit. Okay, you must have understood it. Now relative atomic mass of all element has been found out with respect to atom of carbon 12. Now I tell you one example. Listen it carefully. Let's say average relative mass, or you can just say relative mass of chlorine is 35.5. You will not use any unit for that. This means that an atom of chlorine on average is 35.5 by 12 times heavier than one atom of carbon 12 isotope. So this was the fact, and in this manner you have to understand it. Now students, so far in this chapter we have discussed the atomic mass, then the unit that is suitable to express the data. After that we have understood this concept of relative atomic mass. Now at the end, let's see the atomic masses of various elements. Here a table has been shown. You can see atomic mass of few elements which are present in your NCERT textbook. So this table has been taken from there. You have to remember these elements and their masses. Look, atomic mass, which is expressed in unified mass, that is the unit for it, and the symbol is U. That's why you can see U has been written here. Now, mass of hydrogen is 1 U, then carbon 12 U, that of the nitrogen is 14 U. Oxygen is having mass 16 U, sodium is having 23 U, then magnesium 24 U, sulfur is having mass 32 U, chlorine is having mass 35.5 U, and lastly calcium is having mass equal to 40 U. So this was the concept regarding atomic masses. Go through all the topics which has been discussed. They are important, and in case of any query, let me know. I will help it out. So that's all for today, students. Keep learning.